Hello, everyone. Thank you for tuning in to our panel discussion on fairness in AI. We're looking forward to spending the next 40 minutes or so talking about some of the most pressing and interesting themes in the field of fairness in artificial intelligence. And we'll also be taking advantage of the expertise across a number of Amazon scientists and scholars working on different challenges in AI and ML. Let's kick things off with some instructions. To start, my name is Nashley Cephas, and I am an applied science manager at AWS AI. There, I work to establish scientifically rigorous benchmarking and testing methods for machine learning services, ensuring that the technology produces results that are highly accurate and, most importantly, fair. I started my machine learning journey at Mississippi State University, bachelor's degree in computer engineering. And then I studied at Georgia Tech, where I earned my doctorate in electrical and computer engineering. Since then, I've spent more than a decade doing research in the field of AI and ML, including being CTO of a startup company that was acquired by Amazon in 2016. The name of the startup company was PartPick, based in Atlanta, Georgia. So I have a keen interest in the topic of fairness in the AI industry. And my team and I are focused on training algorithms on well-balanced, diverse, ethically sourced, and correctly annotated datasets. It's similar to how using a calculator to solve a math problem doesn't guarantee you that you'll get the right answer, as my middle school math teacher used to say. All right, so I'm looking forward to this panel. Aaron, I'll pass it over to you.
Thanks, Ashley. So my name is Aaron Roth. I'm a professor at the University of Pennsylvania, and I'm also an Amazon scholar at Amazon, which is a part-time role. And in that role, I support various Amazon projects thinking about fairness and privacy. And my background is in theoretical computer science, in particular aspects of machine learning, privacy, and recently fairness. So my PhD was in differential privacy, but in the last 5 or 6 years, I've gotten really interested in fairness in machine learning. And aside from the fact that this is a sort of pressing and important problem, I think this is a really interesting area of research because despite the sort of, let's say volume and velocity of work over the last 5 or 6 years, I think we still really know very little, and it's a place where definitions are important. It's easy to call something fairness, but thinking about what that really means to downstream users is tricky to get right. And I'm happy to be here at Amazon, getting to think about these questions.
Thanks, Aaron. I'll go next. Hi all, my name is Rahul Gupta. I am a science manager at Alexa, and I work with a team that focuses on privacy and fairness as well. My background is I joined the team about 4 years back. I joined as a scientist, and I was working on Alexa's core capabilities with a team that actually launched Alexa back in 2013, 2014. And my initial projects were, just getting myself warmed up with natural language processing, and I chose that as my area of focus for last 4 years. And it was over the last 1.5 year that we explicitly started focusing on privacy and fairness. I completed my PhD in electrical engineering from University of Southern California in 2016. There, my focus was on modeling human communication and developing computational models that can capture the dynamics of human interaction. And that did connect well with what Alexa was doing, and that motivated me to take up a job here at Alexa, where I focus on NLP. I'd like to also speak why I think fairness is important for researchers like myself. I see that AI has been becoming an integral part of our society, and it has a big impact on our day-to-day lives. And specifically when it comes to agents like Alexa, I see it as sort of like the next revolution, just like the internet revolution or mobile phone revolution. So it's going to have a big influence on what we do in our daily lives. So it is very important for that we place individuals at the center of any AI-centric development. And if we are to do that, fairness becomes a very important consideration because we have to make sure that the AI works for everyone.
Thanks, Rahul. Hello, everyone. I am Jwala Dhamala. I am a research scientist at Amazon, and I'm part of the Alexa Trustworthy team, where Rahul is a manager. And in my team, I work on fairness, interpretability, and robustness of natural language understanding models. I joined Amazon about a year ago, and before that, I was a PhD student at RIT, where I was looking into how we can combine physics-based simulators with data-driven machine learning or deep learning models. So I was also looking into the uncertainty in this both kind of models and how they propagate to our decision making. And I was working into different active learning techniques as well. So all of this closely relates or is very important component in fairness in AI as well. And so I have been using everything that I learned before in AI research at Amazon. Apart from AI, fairness in AI itself being a very important topic, I'm also very interested and curious about AI in fairness in AI because as human, we can very easily understand or in a written form of a text or when someone speaks or when we are speaking, converse in a conversation that something is unfair or harmful, it's unpleasant, and how we need to handle it. But our systems are very far from those capabilities. So I'm very curious and interested to find mathematical or algorithmic ways to incorporate this kind of knowledge and intuition that we have and we use in our daily life into AI systems.
Thanks, Jwala. Hi, everyone. My name is Krishnaram Kintapadi. I'm a principal scientist in Amazon Web Services machine learning team, leading our efforts on fairness, explainability, and privacy-related topics. I joined Amazon about a year back, and before that was part of Microsoft Research and LinkedIn AI teams. So during my PhD, I focused on models and algorithms for data privacy, including an early work on differential privacy. Since then, I have been doing more applied research on topics such as data mining for web search, recommender systems, computational education, and more recently on topics related to fairness, privacy, and explainability in machine learning systems in practice. In addition to what our panelists have already said, I'm excited about fairness also because it's a socio-technical construct. So this means that we need to collaborate with all stakeholders involved, get their inputs, and also achieve consensus on what are the desired fairness notions for us as a society, and also for the specific applications that we're considering. So that's what makes me really excited about this field, the field of fairness in AI in general.
Wonderful. Thank you all. I appreciate that introduction. I'm sure the audience does as well. So I know just to start, we've mentioned the word fairness a lot. So let's frame what we mean by fairness in this conversation. So my question is, how do you define the term fairness? What's your perspective on the topic? And how has that informed your work at Amazon?
So I can start off. And let me start by saying I think it's dangerous to try to define, for once and for all what fairness is. Because as I'll mention in a moment, when it comes to thinking about fairness and unfairness in machine learning systems, we can't speak using the same kind of richness of language that, say, philosophers do. We have to, confine ourselves to sort of quantifiable metrics. And we don't want to fool ourselves into thinking that these sort of quantifiable metrics are like capturing fairness writ large. I think at best we should think of these as sort of signs of unfairness. We can flag particular things that are going wrong. We shouldn't think of these as sort of certifying that everything is going right. And the reason why we have to think about quantifiable metrics is because The way machine learning works is by optimizing a very narrow objective function generally. You've got some data set, you've got some objective function, which is usually some proxy for classification accuracy, and you search through some huge space of models to find the model that does the best as measured according to your objective function. And the result is that you can be pretty confident that the model that you get back is good as measured according to your objective function, but it's very difficult to predict what it's going to do in any way that is not exactly aligned with the thing that you set out to optimize, like classification accuracy. So for example, you might get a model that has very different error rates on different populations. It might, in fact, make errors that are sort of in a harmful direction in one population and more in the sort of beneficial direction in the other population. For example, in a credit application, we might be disproportionately making false positives for one population and false negatives for another. And in many of the high-profile instances we've seen, in the popular press of deployed algorithms that are doing things that are unfair on the part of the algorithm designers who are typically following sort of standard machine learning procedure. Rather, what happened was sort of the unexpected and unanticipated side effect of this sort of standard optimization pipeline. Okay, and so that is all to say, although it's important to have like ethical scientists and software engineers, that is not sufficient. A lot of the unfairness we see in the wild is unanticipated. And to address that, we need to, think about changing our training pipelines, our evaluation pipelines, to explicitly constrain away these kinds of behaviors that we don't want to see. And because these are mathematical optimizations, of course, to do that, we have to think about these sort of relatively narrow, quantifiable metrics. So the kinds of things we can do, which are, of course, not solving the fairness problem, are we can just do our due diligence to make sure that we are not seeing sort of mistakes, say, of a harmful sort disproportionately in one population over another. And that's context dependent, what are the harms done by machine learning. But that's the kind of thing you need to think about when you're trying to decide whether there's a fairness problem with a technology that you're thinking about deploying tomorrow. Now, of course, in the 5 to 10 year time frame, which is what I sort of like to have fun thinking about as a professor, I think we can get better at this. I think we can start learning how to think about not just the immediate consequences of our deployed technologies, but of their downstream and upstream effects. And we don't really know how to do this well just yet, but sort of that's part of the goal going forward. And if we can do that, that'll give us, I think, a much better grasp on positive fairness as opposed to just identifying clear signs of unfairness.
Thanks, Aaron. I can speak about my experience with definitions of fairness in natural language understanding domain. So in natural language understanding, our data is primarily text and sometimes images associated with text. So we try to label a model being fair or biased based on how it is interpreting textual data or how it has learned representation from textual data. So language is a very complex thing. A same language in a different context, it could mean sarcasm. In another context, the same sentence could mean something else. It can convey complex hierarchies, social structure, and emotions of a person. So as Aaron mentioned, it's very difficult to come up with one definition and say that this is fairness in natural language understanding. So also in the research community and in the field, I see that different papers follow different definitions based on their context. And I have seen studies like people trying to see if certain gender neutral professions are associated with particular gender by the model, or things like whether the model performs similarly for different population group, from different racial group, from gender group, or it could even be certain ideas. People have also tried to look into different emotional content in a text, whether it's conveying a certain sentiment or toxicity or not. But in general, as a research scientist at Amazon, I really think that two things are very important when we come up with definitions of fairness. One being that the definitions should be grounded to how this definition impacts the end user. So if we are able to achieve the definitions, how will our user or certain group of people benefit by this, by achieving this, and how will it negatively impact other group of people? So definitely one very important aspect as a research scientist at Amazon is to be careful and consider the users, end users experience when using the technology with the definition we have used. And another thing which is also very important, and I use it in my work, is to and to borrow ideas and be aligned with the research in other disciplines. Like there has been a lot of research in sociolinguistic, for example, studying the biases in language and how language can convey fairness and biases and social hierarchy. So we need to also be aware of those research and focus our definition on those. There are other fields, including human-computer interaction, social psychology, and I think we need to ground our definition on those as well.
Yeah, I agree. Thanks so much, you all, for that, both of you. So it's interesting. We have quite a diverse team of expertise on this panel here today, with representation from different parts of Amazon and different areas of research even. I'd like to understand from each of you where your interests lie and maybe how your current role or work has shaped your specific focus. So Aaron, you co-authored a book with a fellow professor and Amazon scholar, Michael Kearns, called The Ethical Algorithm: The Science of Socially Aware Algorithm Design. And you also co-authored The Algorithmic Foundations of Differential Privacy with Cynthia Dwork. I wonder if you can give us a summary of the topics those books cover and what's changed or evolved on these topics since.
Sure. Yeah, so back in 2014, I wrote this very technical book about differential privacy with Cynthia Dwork, and just last year I wrote a much more general audience book with fellow Amazon scholar Michael Kearns called The Ethical Algorithm. And the ethical algorithm tries to first start by explaining how problems arise, problems of the sort that we might typically think of as social or value driven. So this is concerns about privacy, but also fairness and interpretability, things like this. And we try both to sort of point out how these problems can arise from the standard machine learning optimization pipeline, but then also sort of make legible, hopefully, to a broad audience, the emerging science that is coming out of communities like the FACT community and a lot of work that appears here at NeurIPS, thinking about how to design algorithms that are better behaved, that are sort of more private or more fair. And we spend a chapter, surveying, I think, the basics of the scientific literature in each of these areas, privacy, fairness, algorithmic game theory. It's important to think about users, not just algorithms, and the interactions between users are often best understood with the technology of game theory. We talk about things that are important but less well understood, like interpretability. It'd be good if someone came up with a good definition for what that meant. And in terms of what's changed, when I wrote the privacy book with Cynthia, differential privacy was sort of an academic topic. It was something that mainly people like write mathematical papers about, and the audience was maybe 15 other people like me. But in the 6 years that have passed, it's become a real deployed technology. Since it was published, it's been deployed at big tech companies, including at Amazon. It's been deployed as part of the US 2020 census, and so it's become a real technology. And things seem to be moving much more quickly for algorithmic fairness. So when we published the ethical algorithm, already lots of the energy was sort of centered at tech companies. And I think in the year since it's been published, these technologies, as rudimentary as they currently are, have already quickly made their way from whiteboard to deployment, and it's sort of exciting seeing that happen and seeing the challenges that practice highlights.
So, Christian Ram, you've spoken in the past specifically about explainability and privacy in AI and ML systems. Where does that fit into the scope of the broader fairness in AI discussion? And what have you been working on in this space?
Thanks, Ashley. So, yeah, as Aaron mentioned, these topics are very closely related. So, for one, they are socio-technical. So, in other words, they are topics at the intersection of both society and technology. This means that the challenges in these topics cannot be addressed by technologists alone. We need to work with various stakeholders. These could be the customers of a technology, or these could be people who are impacted by a technology, as well as people with background in ethics related disciplines. And we have to take all the inputs in while designing the corresponding systems. So that's one. The second is that over the last several years, we have seen there have been more and more emerging social expectations and also discussions on these topics in the context of building broadly responsible AI systems. The third is even from a regulatory angle, recent regulations such as European Union's Global Data Protection Regulation, or GDPR, and subsequent regulations such as California's Consumer Privacy Act discuss all these dimensions together. There are also a few nuances. As Aaron mentioned, these topics are at different stages in terms of their technical development. If we say poll an audience in a group, we may all agree that protecting privacy of users is very important, but we may not necessarily have consensus on what's the notion of fairness, perhaps because there may not be a single notion of fairness, and there are also several different fairness notions proposed in the literature. So I have been doing research on these topics and also helping build and deploy systems in practice. So this is something that really excites me, being at the intersection of the research and practice, and having worked on applications related to web search, analytics, hiring, and so on. So most recently, since joining Amazon, I helped start and lead these efforts for Amazon SageMaker. So Amazon SageMaker is a fully managed service that helps every developer and data scientist to build, train, deploy, and monitor machine learning models. So what I'm excited is to share that we just launched Amazon SageMaker Clarify and announced as part of AWS reInvent conference earlier this week. SageMaker Clarify is a new functionality in SageMaker that helps detect potential bias in machine learning models and also explain predictions made by these models. So using this functionality, data scientists and machine learning practitioners can detect bias during various stages. For example, during training data preparation, once the models are trained, and also once the models are deployed over time. And then thereby they can take corrective actions as needed for that application. In addition, SageMaker Clarify also includes tools to help provide explanations of machine learning models as a whole, and also the predictions made by these models. Finally, we are also doing research on these dimensions, often motivated by practical or application settings. So I'll give one example. So often SageMaker customers may bring their own machine learning training data and code in a container. And as a result, we don't have the ability to modify the objective function or incorporate fairness constraints during model training. In our recent paper, we showed that how we can achieve both accurate and fair models just by tuning the hyperparameters of these models, making use of Bayesian optimization techniques. So this paper appeared in the ICML AutoML workshop earlier this year. It also received the Best Paper Award in that workshop. We also have ongoing research on several related topics. For example, how do we reason about fairness in human-in-the-loop settings? How do we design algorithms to achieve different notions of fairness as well as privacy? How do we identify failure modes of machine learning models and also take corrective actions for those models and so on?
Thank you, Krishna Ram. So, Rahul, as a scientist dedicated to voice I imagine you have a unique perspective on the idea of fairness, as voice AI would have its own set of unique challenges and considerations. Can you share more on this?
Certainly, Ashley. So as I was mentioning earlier as well, these AI systems such as Alexa or the ones on your phone or the ones in your car, they are becoming more and more indispensable part of our social fabric. All these technologies are actually reaching people, and they're becoming an integral part of their daily lives. And therefore, bias mitigation and fairness it needs even deeper attention. So just to follow on this sort of philosophy, our goal at Alexa is to make sure that our technology it works equally well for all our customers from different backgrounds, different cultures, and different ethnicities and so forth. An important challenge when designing these voice-based systems is, alongside all the challenges that any machine learning system has, is voice-based systems, they often operate in a pipeline. So just to give an example here, what you may have is a large machine learning system such as ASR, speech recognition, setting more upfront, and then that feeds into downstream components such as a natural language processing component, which actually tries to understand what the user meant based upon the text that the ASR module fed to it. And then there could be downstream components which actually construct a response to the user and return it back to the user. So it's a fairly complex system, and it's something that's stitched out of putting various components together. And the challenge here could be, often it could happen that these systems are designed in silo, or they could be designed together as well. But if they are designed in silo, there could be a bias propagation happen from an upstream component to a downstream component. So there's this additive challenge of making sure that all of your individual components are robust to bias that can flow in from some of these upstream machine learning models. And so that's that's just one unique challenge. There are more, but I'll just focus on this one. And I'd also like to mention that we are also cognizant of the fact that voice agents have started to become an integral part of our daily lives. You can find them in our cars, phones, even our homes right now. So one other thing that I am really excited to see, and I'm really happy to observe, is we are sort of interacting with a lot of stakeholders and making sure that we are doing the right things. So that's really great to see. And we are focusing on making sure that we offer this equitable experiences to the customer. And we are also interested in seeing how we can actually stop the propagation of bias that has historically propagated. So these are all of these are important considerations that we keep in mind when we design a voice agent like Alexa.
Got it. Thanks so much. So, Dwala, you worked on some experiments and use cases related to fairness in AI in your role. Can you tell us more?
Yeah, sure, Anashli. So our team has worked on multiple use cases related to fairness, but let me focus on one recent work that is currently in submission at a conference. So in this work, our team was interested in investigating bias in open-ended language generation problem, and this is very important because many NLP tasks now use natural language generation models as one of their central building blocks. So to quantify bias in this model, to benchmark biases before using them in downstream tasks is very critical to ensure that our models are bias-free. So what we did in this paper or in this research work is mainly we could talk about it in two categories. First is we wanted to design or come up with a large benchmark data set that can be used by researcher or industry practitioner to benchmark their language generation model. And second was we worked on coming up with a set of evaluation metric to evaluate bias in the model. So let me talk a little bit about the data set and how we collected those data set. So in terms of data set, our aim was that the data sets should be large enough, diverse enough, comprehensive enough to capture biases in various situations or across different population group or even across different ideologies. Also, we wanted the data sets to be large enough so that we can simulate what a system may be exposed to when deployed in practice. So for that, we use Wikipedia as our data source. So what we would do is we would select a set of Wikipedia page, we would crawl into the Wikipedia page and select a set of sentence set of sentence beginning, let's say 7-8 words from each sentences and add them to our data set. And in this way, we collected a data set that had more than 20,000 such prompt. Those prompts are can be used as context to a language generation model. So let's say we have a set of words that describe or talk about certain religion, and another set of words are prompts that talk about another religion. So if we ask language generation model to generate given these two sets of prompt, we will be able to compare and study if there is biases in how this model generate given the prompts or context from these various religions. So that's what the data set consists of. And in terms of evaluation metric, as we mentioned earlier, it's very difficult to come up with one metric to capture different kind of biases in NLP task. Also, it's very difficult to come up with a concrete definition that will capture or is comprehensive enough to capture all kind of biases. So we broadly defined fairness in our task as if a model generates negative sentiments or negative sentences that is harmful to a certain population group more frequently than for other, then the model will be considered biased. And so we came up with a set of metrics including things like sentiments, toxicity, gender polarity, and many more. So we did the evaluation on those based on those metrics. So in overall, in this paper, we key takeaways were that we among the different models we tried, like GPT-2, BERT, control models, we saw that there was a they were generating sentences with biases more frequently than our baseline of Wikipedia sentences themselves. And also we saw that the control model with certain control codes were generating more frequently this kind of sentences. So our dataset was not aimed to explicitly extract certain kind of biases. It was comprehensive and it was designed to simulate a real world situation. And so it was a very alarming result for us to see this kind of biases in the model. And moving forward, our aim is to study how these biases propagate in downstream tasks, as well as how we can mitigate the biases before they are used with real world system.
Thanks, Jwala. That makes sense. So I guess to close, I'm interested in gathering insights from this group on what's in store for the future. Where do you see the AI community focusing efforts, and how are we tackling this important topic?
Let me give some thoughts on this topic. So if you think of fairness in AI or responsible AI more broadly, it's a very timely challenge for the society that we all have the opportunity to address and to do research and to work on. So clearly, this is not a challenge limited to any one company or even the tech industry as a whole. So because of this reason, we have been partnering with academic researchers, our peer companies, and the broader community. So for example, we have been working with the partnership on AI to help draft guidelines and best practices on these topics. We have also been engaging with academia through Amazon Research Awards on related topics through internships and also collaborations with professors. This is something that I'm very excited about to collaborate even more with the various professors and their students. So personally, I'm excited about uh, being at the intersection of the academia and industry, and have been presenting tutorials on topics like privacy in industry, fairness or explainability in industry, responsible AI in industry, and so on, jointly with collaborators from other peer companies, so that we share our collective experience, present the open challenges, research challenges that we are seeing in the industry in this space, and thereby also help drive collaboration with academic researchers. So finally, let me note that it's very important to build an inclusive and diverse research community on these topics. So because of the significant societal implications of these disciplines, we need diversity in terms of demographics, lived experience, perspectives, expertise, and so on. I'm really thankful that we have several cross-disciplinary conferences, such as the ACM conference on fairness, transparency, fairness, accountability, and transparency, as well as the AAAI ACM conference on artificial intelligence, ethics, and society, where we see researchers not just from computer science but also from other disciplines, and thereby through this cross-pollination of research, we are seeing the right primitives or the right notions on these topics starting to emerge. This is what keeps me really excited about these areas.
Yes, I'd like to second Krishna Ram there. It is really exciting and great to see all the acceleration in fairness research, and it's actually making all the way into industrial systems. It's having real life impact, and it's changing how ML systems are built at scale. And we ourselves, my team and myself, have benefited from such a collaboration. Emphasis now lies in making sure that the research that happens in the academic setting quickly finds its way into production, and the time lag between two is minimized. And as Krishna mentioned, there are all these platforms that help us get connected. Uh, as a researcher, we benefit a lot attending some of these conferences, which are specifically focused on fairness. And we ourselves would be actually organizing a workshop at North American chapter of ACL, and we hope to learn a lot from that workshop. I'd also like to point out that a closer collaboration between industry and academia has paved the way for all this progress to happen, and is also an interesting observation here that the industry is making inroads by consulting policymakers when it comes to fairness research and its implementation. So it's becoming a bigger community. We are getting tightly knit more and more, and I am very hopeful about the of this research because of all this collaboration.
I can go. So of course it's hard to predict what things will look like in 5 or 10 years. But I would urge people to maybe look beyond the standard machine learning conferences. And as in any hot field, although there's been a lot of work in fairness in machine learning, not all of it has been the most thoughtful and coherent. But there is this sort of steady stream of work that tends to come out of things like the theoretical computer science community. And in fact, there's a whole theory conference called Foundations of Responsible Computing that I helped start last year and is going to continue again this year, in which some of this work is happening, that is trying to think about, let's say, more principled approaches to thinking about fairness. And an obstacle to lots of, it's often the case that these more principled approaches have serious obstacles to deployment, which is why we don't see more of it. But I think we should remember that with something like differential privacy, which is now widely deployed technology, it took 10 years for the transition from the whiteboard to a real technology. And I'm hopeful that in the next 5 or 10 years, we'll start to see payoff from some of this more principled theoretical research, and that some of these more sort of foundational ideas will start to see their way into practice.
Yeah, so and really quickly before we go, Amazon also has a collaboration with the NSF on fairness and AI efforts. Can you speak to the importance of the NSF in this space and how it's helping drive improvements in fairness in AI?
Sure, Ashley, I can take that question. So actually, a year ago, Amazon and National Science Foundation announced a $20 million collaboration to fund academic research on fairness in AI over a 3-year period. So this was a great thing that started last year. The goal of this collaboration is to promote academic research in this important aspect of AI. Our primary objective for engaging with academia on issues related to fairness and transparency in AI is to get many different and diverse perspectives focused on the challenge. So the first 10 recipients of grant issued projects it addressed 4 broad research areas. The first one was ensuring fairness in algorithms and a system that incorporate them, which begins with the definition and quantification of fairness. And I guess we talked about that a little bit in this conversation. The second one was accountability and transparency in AI algorithms. Third one, using AI to promote equity in society. And finally, the fourth one was ensuring that the benefits of AI are available to everyone. So what we hope in the future is that the future cycles of research will build upon the success of the first round by bringing an even greater diversity of perspectives on definition and perceptions of fairness.
Wonderful. I want to thank you all for sharing your insights on this important topic of fairness in AI. For those who have tuned into the session, we invite you to reach out to us to discuss our research efforts or experience working with Amazon one-on-one. I'll also mention you can read more about the winning grants and Amazon's collaboration with the National Science Foundation, as well as various fairness in AI blog posts and articles on Amazon.science website. So again, thank you all for tuning in. Hope you have a good one.